Okay, so let's do this axial member problem using the SMATH. Okay, by the way, SMATH is a freeware, so that's why madalas ko siyang gamitin sa tutorial, like this. Now, if you will notice, ito yung formulation ng axial member in a global sense, which I showed here. Ito. Yan. And remember, K global came from this formula. T transpose, then the K local times T. Okay. T means the transformation matrix, which is this. No? It's just a function of theta, no? Cosine and sine. Okay. Then AE over L, which we derive in the other video. Okay. This is the T transpose, and then this one is the T matrix. And then operate that T transpose K and T, you get this. Okay. Which we will now use in our SMATH. Okay, ito siya. Kinopy-paste ko lang. And yung formulation niyan is here. Okay. Cosine square, cosine sine. Ito. Negative cosine square. Okay. Negative sine cosine. Okay. Cosine sine. Okay. Sine square. Okay. Negative sine cosine. Ito. Okay. And then negative cosine square, and then ito negative cosine square. Okay, then AE over L, AE over L. Okay, our problem now is this, which I got from Casimali also. Ito. Okay, I think ito ba yun? Okay, ito. Example, yeah. Now, this came from Casimali also. So, given yung mga loads, okay, yan, 1, 2, 600, 4,000, 3,000, 4,000. Okay. So, ano lang natin, sketch lang natin dito. Okay. So, this is our problem. Yan. 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 Medyo ano lang ako, no? Hindi na maganda yung okay. Pwede ko na lang, no? So, first, let's decide member 1. No? I'll decide this is member 1, this is member 2, and then this is member 3. Okay, then nandito yung mga loads. Yan. Yan. Okay. Now, the equation for stiffness method is P equals KU. So, we need to get the K local of each of this. Okay, so K1. Okay. Then we have K2, K3. Or K1 global, no? K1 global, K2 global, K3 global, which is this, no? Ano natin, no? Okay, so pwede ko itong i-copy ulit. Control C, then paste here. Oops, not that one. Control C, Control V. Yan, okay? So, apply mo to dito. Okay? Okay. Okay, so, gawan ko lang ng yan. For example, dito. Yan. 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 Now, if we isolate each member, okay, isolate ko siya. Isolate ko. Okay. Remember, itong ginagawa natin, this is the way how the software works. No? Ganito din mag-work ang STAAD, even ETABS, lahat ng structural analysis software. Because, yun yung kinaganda ng stiffness method. In general, finite element. Although, nagkakaroon tayo ng mga equation, ng mga displacement function, pero ultimately, it will be a matrix analysis. Now, for the matrix analysis, from the word matrix, it's all numbers. And when you talk about numbers na nare-read ni computer, you can make a program na procedural na mechanical na lang. No? Kumbaga, automatic na lahat. So, this is how STAAD works. For example, our member 1, gagawa siya ng coding for that. Okay. For example, member 1 is this. And take note, meron tayong 2 degrees of freedom for each. So, lalagyan ko to ng code na 1 and then 2. And on the other end, 3 and then 4. Okay. How about member 2? This is member 2. So, ang code naman nito is 5, 6. And then yung dulo naman niya is the same 3 and then 4. And then lastly, number 3. Ang code naman nito ay 7, 8, and then this is also 3 and 4. Okay. Again, this is number 3. Okay. So listen, no? Halaga to, no? Take note, very important, saan yung start node tsaka yung end node. Start node, end node. Start, end. Okay? That means, you should be consistent then on applying this code sa ating formula here. Okay? For example, sa member 1, 1, 2, 3, 4. Therefore, pagdating mo dito sa stiffness matrix for each member, consistent dapat yan. Okay? This should be, remember, ito ay, where's my mouse? Okay. Member 1, this will be 1, 2, 3, 4, 1, 2, 3, 4. And then for member 2, 5, 6, 3, 4, 5, 6, 3, 4. And then last, member 3, 7, 8, 3, 4, 7, 8, 3, 4. Okay? Kasi, we mean to say na this is the start node, 1, 2, start node, 1, 2, start node 5, 6, start node 5, 6, start node 7, 8, start node 7, 8. Okay, consistent. Okay? And this is also consistent with the size of the matrix. Remember, ang K natin is 4 by 4. Okay? Our K is 4 by 4. Yan. Kumbaga, pwede ko yung lagyan ng 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Yan. Okay? Maximize ko lang. Then view. Maximize. Yan. Okay. So on and so forth, no? So that's it. Now, once we got the K of each member, okay, pwede kong gamitin na yung next step. Your P equals SD. Yan, no? Parang P equals KU lang din, no? Pero kasi in terms of, dahil ang reference ko sa SMATH kasi mali, so sinunod ko lang siya dito, no? S is the structure stiffness matrix. Structure stiffness matrix. Okay? And D is the displacement, of course. And P is the force vector, which we have kasi nga may given na load. How do we get the structure stiffness matrix? Okay, save ko lang. Axial. Safe. How do we get the structure stiffness matrix? The structure stiffness matrix will come from here, yung mga contribution ng mga stiffness matrix of each member. Okay, how do we know that? So, first, determine to get S, determine the unknown displacement. Yan. Okay, determine the unknown displacement. Nasaan ba yung unknown displacement dyan? Take note, ito, pin support, pin support, pin support. So, ang unknown displacement mo, itong dalawa dito. Okay, therefore, in this case, we have two displacements. Which, anong code? Ang code ay 3, 4. Okay, see? So, ganun ka-importante yung ating coding. Yung two displacements natin corresponds to 3 and 4. Remember? 3, 4, 3, 4, 3, 4. That means, ang kailangan natin pick upin from this K will correspond dun sa 3 and 4, which is, anong address nun? Ito. Yan. 3, 4. Yung dalawa dito. 2 by 2 dyan. Tsaka ito. Okay. So, yung mga laman ng matrix na yan, that will comprise the structure stiffness matrix. Okay. So, therefore, our S is what's the size? 2 by 2, which has a code of 3, 4. Kasi nandyan yung displacement natin. So, kukunin, pipick upin natin itong mga to such that dito sila mapupunta. Okay? And using SMATH, yun na yun. Okay? So, ginawa ko na siya ng code. Ito yun. Niloop ko siya for 1 to 3 members kasi nga, 3 members tayo. And what I got is, so ganun din, 3 members, so I need to have 3 rows of area. So, try natin, input natin itong, okay, area is 4,000, put ko, next is 3,000, and then last is 4,000. How about the length? So, if you notice, ang length natin is 3, 4. So, therefore, this is 5 meters. Lagay ko muna 5,000. Then, this is 3,000. And then, 5,000. Okay. What's the elasticity? 200. So, input ko 200. And then, the theta. Ang theta ko ay ito. So, 3, 4. Remember, ang formula lang naman natin ng theta is ito siya. Okay. This is 4. This is 3. So, ito yung theta natin. No? So, theta is arctangent 4 over 3. Which is what? So, shift tangent 4 over 3, that is 53.13 degrees. 53.13 degrees. Kaso yung SMATH dito, code ko, it should be in radian. No? So, ano yung equivalent radian yan? Times pi divide 180. 0.927 0.927295 rad. Yan yung radian niya. So, 0.927. So, tama lang to. Then here, 90 naman to. No? That is pi over 2. Ito, okay, same sila ng theta. Pero take note, yung derivation natin ng stiffness matrix, pag ganito, di ba? Yan, pag ganyan yung stiffness matrix. Pag ganito to. That's why, and then yung theta natin is here. So, not consistent. That's why I use theta as negative. Okay, negative of this. 0.927295. So, that's it. So, this should now be okay na. Okay, K1, K2, K3. Okay. So, that's it. Meron na akong K1, meron na rin yung K2, meron K3. Now, using yung ating diniscuss dito, we should get all here. Yan, yung mga nandyan. Kakailanganin ko ng code na to. Okay? So, explain ko lang. No? For my BU, this corresponds dun sa address ng cells na i-extract natin. Okay? For example, andito sa K1, ano yung address niya? Third and fourth, right? Third and fourth rows and column, third and fourth rows and columns. Ganun din sa K2. Third and fourth, third and fourth, third and fourth, third and fourth. Kaya, ang nakikita nyo dito, 3, 4, 3, 4, 3, 4. This is member 1, member 2, member 3. How about sa BB? Ano ngayon yung magiging address ng mga to sa S natin? Okay, if you notice, 2 by 2 lang to. Therefore, yung 3, lahat ng 3 mapupunta sa 1. Lahat ng 4 mapupunta sa 2. That's why, ang code ko dito, 1, 2, 1, 2. Okay? So, that's it. And, sorry, medyo, S4 na kasi yung nakasanayan ko dito. Just to make a unique variable name. Yung S4 naman, kailangan kong mag-create ng zero matrix muna. Na kasing size ng S. Okay, ang S natin dito is 2 by 2. Therefore, yung S4 matrix ko is 2 by 2 din. Na ang element ay puro 0. Which is this. Okay? So, once na-settle mo na yan, kailangan mo na yung code na to. Okay? This generates the stiffness matrix. Actually, hindi na kailangan to. Delete ko to. Lagyan ko lang 1. Yan lang, no? Saka ko na lang explain later yung meaning nito, no? Pero, ako nag-code dito. Inisip ko to how to do this. Pero, syempre, may pattern. May pattern naman lahat, no? So, using that, magkukuha ko yung S matrix ko. So, this is now the S matrix. Okay, so save as ko lang. Okay, save. And then, okay na yun, no? Meron na akong S. How about the force vector? Yan, no? How about the force vector? So, P equals SD. May S na tayo. May force vector din tayo. So, ang S natin is 2 by 2. Ang P natin, to be consistent, this should be 2 by 1. To get a D, or the displacement of 2 by 1. So, consistent yan. No? This is 2, this is 2. So, I will get 2 by 1 here. 2 by 1. So, equal sila. Okay? Sige, kopyahin ko lang saglit tong S. Copy this. Then, paste. So, ito yung S natin. How about P? So, gawin ko na yung P dito. So, our P that is 2 by 1, rows ay 2, column ay 1. So what's the value? So what's the value of that? Syempre given yon, no? Which is 1, 2, and 600. Okay? 1, 2, and 600. Okay. Yung 1, 2 is ito. 600 ay ito. So, anong address niya? Okay. Remember the consistency. So, P equals SD. Ang S natin, ang code ay 34. So, ang P natin, the code should be 34. Okay. To get the displacement na ang code ay 34 also. So, P so our P should have a code 3, 4. Si 3, remember, horizontal, that is 600, while si 4, 1, 2. So that is 1, 2. Take note, pababa siya, so negative. So input natin yan, 600 and 1, 2. That is 600, negative 1, 2. Okay? So D equals S4 then exponent negative 1 space bar para to capture the whole S4, then saka mo ita-type yung multiply, which is asterisk, and then P. Okay, then click outside. So walang error, so hindi nagpula, so walang error. So type ko ulit si D, and then N equals, so yan yung ating displacement. So therefore we have a displacement of negative and then negative. Okay, is this correct? How do we know na correct siya? Siyempre, check natin sa ano, no? Sagot. $696 600 negative 1 2 but hindi consistent. Okay, tingnan natin yung ano, yung input natin. Baka may something wrong sa input. Mali yung ano ko, mali. Iba to, no? Naka-English nga pala to. So, I'll see. Okay, so gawin na lang natin. I may do a STAAD. Okay, so to do that, ito yung interface ni STAAD. So, para naman ma-double check natin yung result ng SMATH. So, new, and of course, plane. Kasi, two-dimensional lang tayo. Meter, kilonewton. Gawin kong piliin ko yung address natin dito. That is an FEM. Lagay ko na siya dito sa matrix. Gawa ko ng folder. Stock. Copyhin ko to. Then paste ko dito. And then action. Okay, next. Finish. And so we'll start with the modeling. Close ko muna to. Start ako sa 0. Okay, take ang ating this is 0, 0. Therefore, this is 3. And then this is x. This is 6. So, 3. Then 6. Then we have 3, and then 4. Ayan, okay. So, ito yung ating mga nodes. Front view natin para makita sa elevation. And then, click mo tong add beam to model. By default, beam ang tawag ni STAAD sa any line member. Pero we will assign that as a truss member later on. Pick, and then pick, pick, and then pick, pick, and then pick. So, to be consistent with the theory, while I pick, you notice, nagkakaroon siya ng node dito. Node A, node B. That means, ito yung node A ko, that becomes the start node. Ito yung node B ko, yun yung end node. Para consistent dun sa derivation natin ng K-matrix. Start, end. Na ang code ay 1, 2, 3, 4. Okay. Then, escape ko lang. So, ito na yung ating member. Click ko na yung general to assign property. And then, define. Okay. Mag-define tayo ng circle having area na kagaya nito. For example, 4,000. Ano yung diameter niyan that will correspond for an area of 4,000? So, I will compute for that. Pi d square over 4 is 4,000 times 4 divided by pi. And then get the square root. So, I got 71.36 mm. So, that is about 0.071365. 0.071365 meter. Then, ang ating material ay steel. Steel. Okay, and then add. Next is yung 3,000 na area. Okay, then square root of that, 61.8 mm. So that is 0.0618039. Then add, close. So, dito na yung define natin na circular steel member na may area na corresponding do sa problem natin. So, ito yung 4,000. So, select this. Select ko to. And then, press control. Then, select mo din to. Okay. Then, selected. And then, assign. So, ganun din dito. Yan. Okay. So, you will notice, pag nag-3D na ako, right-click. 3D. Yan. So, meron na siyang property. Na-incorporate na yung circular steel member. So, next is the support. Create. Pin tayo. Then, add. Siyempre, select the command. And then, assign to the object. Okay. And then, assign. Yes. Pin support na. Then, finally, load in definition. Click. Then, lagay tayo ng isang load case here. Click mo to, then click add. Okay. Add ko lang. Close. Then, lagyan natin ng laman to. Okay, so on. Then, add. Yan. Then, input natin yung forces dito. 1, 2, and 600. So, they are acting at the joint or the node. So, they are nodal load. So, that is negative 1,200 because downward, Fy, and then 600. So, going to the right, Fx. Okay. Then, add, close. Siyempre, select the command and assign dun sa node. Ayan. You notice, by default, hindi ka naka-nodes cursor. Kaya, click mo muna yung nodes cursor para ma-assign mo to dito. Diyan, no? So, select ko to. Selected yung command. Selected yung geometry. and then assign. Assign, yes. Okay, so okay na tayo. Then click na natin yung analysis. Lalabas to. Click mo lang yung add. Yan. So na-define na natin yung material, yung supports, yung load. So, pwede na tayo mag-analyze. Okay, so click ko yung analyze, and then run analysis, then save. I want you to take note dun sa run analysis ni STAAD. Tingnan natin, no? Processing joint coordinates, processing member information, reading member properties, calculating, take note, dito sa ano, no? Processing and setting up load vector. See? So, kinumpit din niya yung P vector natin, no? Doon sa formula natin ng P equals SD. Processing element stiffness matrix. See? Kinukuha din niya yung stiffness matrix of each element. Okay? So, that is our S matrix. And then, once na na-complete na niya yun, makukomplete na rin niya yung structure stiffness matrix. Saka pala niya makukuha yung displacement, creating displacement file. Diba? Kasi from the formula P equals SD, meron kang P, meron kang S, that's the time to invert the matrix S, you get the D. Okay? Then saka pala makukuha yung reaction and then the section forces. So that means consistent si STAAD dun sa theory ng ating matrix analysis, which is the same with the finite element. Okay, so click ko yung done. Punta ako sa post-processing. Then, okay. Displacement. O, ito yung nakuha natin. So, node 4. Ang displacement daw is 5 mm tsaka negative 3.3. So, ito dapat yung makuha natin displacement sa node 4. How do you know ano ang node 4? Press nyo lang yung shift N. Shift N. Okay. Nakita ko dito open node. Meron ako dito niyan. Shift N. Okay, that's it. Ito yung to display the nodes, shift N. Okay. Tayo sa STAAD. Okay, ito siya. Then, kung gusto mong ma-imagine yung displacement, press mo lang yung control and then yung wheel button ng mouse. Tingnan nyo, no? Ayan. Na-exaggerate yung displacement. Okay, and then ito yung node 4, 5 and negative 3.3. So, balikan natin yung SMATH natin. Dapat ang makuha natin is 5 and negative 3.3. Calculation, recalculate. So, tayo nagkamali dito. Okay. Okay, ito, no? Negative sign cosine to. Negative. Yan. Bigyan ko ng negative. Let's see. Calculation. Recalculate. What else? Ayan. So, yung pala, no? Kailangan lang natin yung pi over 2, palit ako ng radian na 1.570796. That's it. And then ito, kinorek ko lang to, yung formula nito. So, I got 5.2 and negative 3.38. 5.2 and negative 3.3. So, medyo close enough naman yun. But there's a reason, no? Bakit sila may discrepancy ng ganon, no? So, save as ko lang. I'll show you why, no? Punta ko dito sa STAAD editor. Balikan natin yung properties ng steel. Ayan, no? If you look at steel, ano yung kanyang E? 205 gigapascal. See? So, palitan ko siya ng new name. Control C, Control Lagyan ko ng asterisk para to differentiate. Gawin ko tong still JP. Okay. Then gawin ko tong 200 gigapascal. That's it. And then, palitan ko to ng JP. Okay, because ang i-call ni STAAD is yung new name ni still, which is this, and not this. Okay, so save ko lang siya. Let's see kung may changes. Close. Oops. 10 errors. Ano kaya yun? Kasi nga, hindi ko siya inassign. There's that. No. I have. Ito lang, no?